This is the ease website that we have here. You can find that online, of course, under ease.afmg.eu. And we have a section down here for Ease Speaker Lab, which refers to the loudspeaker data. And if I switch over here, we have a brief description. You see different balloon data types here. But what I'm mostly interested in is this is a comparison of the different loudspeaker formats which are available on the market. So obviously there's a different simulation tool called Ulysses. They use UNF data. The CLF data is called Common Loudspeaker format, which is shared by many other manufacturers. And then we have the EASE GLL data. And just by quickly comparing these tables to one another, you see that the EASE GLL data is not only providing a much higher resolution, which can be scaled a lot better, especially at high frequencies, but very important aspect, the phase data.
This is important, the phase
data.
This
is very, very important for high quality simulations. You see that the UNF format does not support phase at all. The CLF data, it does support phase, but it's an averaged phase, which is averaged across a third octave.
Okay.
And you may know how much in the phase variation can be at a third octave. That means, especially at higher frequencies again, the simulation result for phase data, according to our perspective that we have, needs a lot higher resolution than third octave average data. And this is why AFMG has designed the GLL format, which can use actual impulse responses then again, which have all the information not broken down to third octaves, but floating across the whole frequency band, you have the full information in there. And then if you take a simple look at the other checkboxes that we have for different things which are supported, filter networks, using multiple transducers in one
right
GLL.
Now, the array line array speaker, they do have multiple drivers.
Of course, and what we say again is for the loudspeaker manufacturers, please measure one cabinet separately, so measure the low mids, measure the high mids, and measure the high transducers separately. But with that, because with that you even get a higher resolution in the simulation data than if you would be measuring everything at once.
I see.
So the mathematical processing which is done by EASE or by Speaker Lab produces a mathematical resolution which is a lot higher than the 1 degree resolution that the actual measurement data is limited to.
Yes.
So with the GLL format, we already have a higher measurement resolution available to manufacturers, plus that the mathematical processing behind actually produces an even higher and more accurate result than the simple measurement data that you would be picking up with other formats.
Okay. The common question that I get from other engineers in Indonesia is, how are you certain, how you can be sure that the result is accurate, how accurate it is?
Well, the simple answer to that is actually EASE is doing purely mathematics. So all the formulas, all the calculations done by EASE have been proven for probably over 100 years by theoretical approaches, by mathematicians all around the world. That's all that is done by EASE. So there's no magic involved. It's just a very, very high-end calculator, which allows for you as the engineer to be saving a lot of work, to be doing calculations which are so time-consuming otherwise, with a very neat tool which can save you a lot of time and which can come up with much more correct answers, because it's all pure mathematics, so there's no magic involved around that. So that's the very simple answer. If you're interested in how good the EASE data represents the actual projects, there's many documentation on the internet available. For example, the Audio Engineering Society, many people produce papers for the AES again and again and again. You can find all of that online, different papers, different aspects. be it loudspeakers in churches, which have been proven, be it loudspeaker use in tunnels, which has been proven, be it loudspeaker use in all kinds of different settings as well, open air settings, for example. So EASE is used globally, commercially by now on a very large scale, and all these different things, since they rely on simple mathematics, have been proven. The important thing, as we said earlier, the quality of the input data distinguishes the quality of the output data.
That's very important.
So it's up to you as the engineer to make sure that your data is correct.
One last question. I hear that EASE can make us listen to the room before even the building is itself being built. Can you explain that a bit?
Oh, that's a very interesting question. And actually, myself coming from the marketing side of AFMG, I see two different aspects for that. So with EASE, there's an additional module to EASE, which is called ears. So ears for the ear.
Yeah.
Which means, or which actually enables you to listen to the results of the impulse response which has been calculated by your simulation. So again, you set up the calculation, the quality of the calculation determines the quality of the output format, but then you can actually use live voice data or any recorded audio and convolve that with the calculated impulse response, which would produce a live audio which you can use on headphones, for example, or on a dedicated listening system. By now we're supporting the Ambisonics B format as well, which would give you a multi-channel playback, up to 9 channels supported for very high-end listening settings. From my perspective, that's interesting for two aspects. One is that the engineer, you again, can listen into the room to be hearing results which you could probably not see in the graphical data. So reflections from a balcony or wrong wall materials have been used, so you're getting like a very high frequency reverb, whereas the low frequency reverb dies off very fast, so you will hear things like that. Flutter echoes and other things which are very hard to see in the little data, you can actually listen to them. Plus, from a sales point of view, you also have the chance to play the audio to your customer, and then your customer can very nicely differentiate between a room which has not been treated with acoustical materials, for example, the differences that different treatments will be making, the differences that different loudspeaker setups will be making, different loudspeaker brands will be making. So all of that can be heard very nicely in the oralized result, which you can do with the ears module.
Okay, so that's all, folks, here from Berlin, Germany, and thanks again to Mr. Thilo here. Okay.
Thank you, Leo.
See you next time.
All right. Thank you.
Thank you.